Hello and welcome to Cornerstone Christian Academy's virtual science fair. This is the fruit of 3 months worth of investigation in the areas of physical, life, and earth sciences for our middle school students that are comprised of grades 5th through 8th. They've worked very hard, they've investigated, they've come up with hypotheses, they've tested those hypotheses. They have data. I want to take the opportunity to thank our administration, staff, judges, parents, and our students in advance of this wonderful science fair experience. Sit back, look, explore, and be inspired. Thank you.
Ever wondered how healthy and smokers' lungs work? By Bree Williams, 5th grade. As you can see, the healthy lung is on the left side, while the smoker's lungs is on the right side. Healthy lungs look and feel like sponges. They're pink, squishy, and flexible enough to squeeze and expand with every breath. Their main job is to take oxygen out of the air you breathe and pass it into your blood. Smoker lungs appear dark and mottled due to inhaled tar. It can damage your lungs along with your airways and your small air sacs. The texture of damaged lungs is much harder and more brittle. What do smokers' lungs feel like? Toxins make the tiny airways in your lungs swell. This can make your chest feel tight and can cause wheezing and shortness of breath. If you continue smoking, then inflammation can build into scar tissue, which makes it harder to breathe. How do you know if your lungs are healthy? A spirometry test measures how healthy your lungs are and can be used to help diagnose and monitor lung conditions. During the test, you will breathe out as much air as you can, as hard as you can, into a device called a spirometer. Here are the materials I used to help me complete my project. Duct tape, 2 straws, 1 clear plastic bottle, 3 balloons, clay, and scissors. Here are the steps I used to complete my project. Step 1. Cut the bottom of the bottle. Step 2. Place clay inside of 1 straw. Step 3. Tape 2 balloons to 2 straws. Step 4. Put the 2 straws through the top of the bottle with the balloons hanging in the bottle. Step 5. With the straws hanging out of the bottle, put a hole in the bottle cap. Step 6. Cut another balloon and put it at the bottom of the bottle. Wrap duct tape around to seal the balloon. And step 7. When you tug the bottom balloon piece, you'll notice the suction created in the bottle. Here is the last slide. Here is a video of an example of how I completed my project. If you look closely into the balloon, you can see that the healthy lung, which is the red one, is expanding with no problem. While the orange one, the smoker's lungs, is not expanding as much as the healthy lung.
Today I'm presenting my science fair project, homemade lava lamp. Purpose. I did this project because I wanted to try something new. I have done science projects in the past that didn't seem interesting. I like things that glow in the dark too. Hypothesis. Even if it only lasts for a few seconds during this project, oil, water, and oil will unite without difficulty. materials: an empty Gatorade bottle, red food coloring, vegetable oil, August seltzer, tablets, and water. Procedure: I pour out the juice from a Gatorade bottle into my kitchen sink. I pour vegetable oil into 3/4 in the bottle. I pour water inside of the bottle to the top. Immediately, the oil and the water began to separate from each other. I added 25 drops of red food coloring into the bottle. The water became red, but the oil didn't change colors. I added 8 broken pieces of August seltzer tablets inside of the bottle, and I put the cap on. Results: this mixture began to fizz and it became very bubbly. I shook the bottle upside down and the oil and the red water remained separate. I turned all of the lights off and placed a flashlight under the lamp and it glowed in the dark. It was bright yellow color, but the red part didn't glow. Conclusion. In conclusion, I discovered that my hypothesis was correct. Although the water and oil segregated from each other, that this didn't cause any difficulty during the experiment. I was surprised that the red coloring didn't affect the color of the oil. I was surprised that the oil didn't change to red. When the water and the oil were separating, it happened fast and smooth. It was interesting to see the fluids change positions because I poured the oil in the bottle first and I put the water in second. However, the oil shifted to the top of the bottle and the water dropped at the bottom of the bottle. First mixture with oil and water. Food coloring and August seltzer added in a mixture. Final results in the dark with flashlight. Thank you.
Volcano Eruptions by LBH, Science Fair Project, March 15, 2021. Question: will the volcano eruption be intense if more dish detergent, soap, vinegar, or baking soda is added? Hypothesis: if I add more dish soap, I don't believe the eruption will be more intense because the chemicals in dish soap are not strong enough to get a more intense chemical reaction. It will produce more bubbles. If I add more vinegar, it may add a little more fizz to the eruption, but again, the ingredients in vinegar alone will not produce a more intense reaction. I believe if I add more baking soda with the correct ratio of vinegar, it will produce a more intense reaction because the chemicals in baking soda, sodium and bicarbonate ions mixed with the chemicals in the vinegar, hydrogen ion and acid, will produce carbon dioxide gases and an eruption will form. Make a volcano. Get a glass bottle, a cardboard box, mixing bowl, table, and newspaper. You will need 6 cups of flour, 2 cups of salt, 4 teaspoons of cooking oil, and 4 cups of water. As the mix starts to form a dough, stand the glass bottle up and wrap the dough molding around the bottle. Leave the top of the bottle with the hole open. Let stand and dry. If you want your volcano to have color, add food coloring with the mixture. Ingredients to cause a volcanic eruption. Add 6 drops of detergent and 2 teaspoons of baking soda and mix slowly. Add 1/2 cup of vinegar in the bottle. You will start to see the magma pour out of the top of the volcano. Next, add 9 drops of detergent, 2 teaspoons of baking soda and mix. Slowly add 1/2 cup of vinegar in the bottle. The eruption will produce more magma. Reduce the detergent back to 6 drops and 2 teaspoons of baking soda and mix. Slowly add 1 cup of vinegar in the bottle. You will see a more intense eruption. Finally, add 6 drops of detergent, 1/3 cup of baking soda and mix. Slowly add 1 cup of vinegar in the bottle. The eruption will be much more intense and the magma will flow at a faster rate.
Hello, my name is Gary. My science field project is on volcanic eruption. My hypothesis is that I believe that if you add more of one ingredient, the radio of the eruption will be more intense. And I tested my theory several times, and here are my research experiments. 6 drops of this detergent, 1/3 cup of baking soda, then 1/2 cup of vinegar. I test my theory of changing the experiment to get more bubbles and foam out of the volcano. To do so, I add 9 drops of this detergent, 1/2 of baking soda, and lastly, I add 1 cup of vinegar. Intensity rate that the magma flows from in the volcano is more intense when I add more baking soda.
Conclusion. My hypothesis is true. Adding more baking soda will result in a more intense reaction than adding more detergent or vinegar alone. The correct ratio of adding more baking soda and vinegar produces a more intense volcanic eruption.
The eruption of a volcano can be one of the planet's most destructive events, spewing huge amounts of rock, gas, and ash that can kill people, cause crops to fail, disrupt air travel, and even alter the weather. But not all eruptions are cataclysmic. Some are a lot quieter and far less deadly. There are many types of volcanoes, but all are cracks in the earth with a chamber of molten rock or magma underneath. The hot magma is lighter than the surrounding rock, so it rises. As it does, gas bubbles form, increasing pressure. The magma starts to flow, taking the path of least resistance. Once the magma reaches the surface, it's called lava. If the lava is thin, the gases will bubble out easily and the lava will flow quietly. But if the lava is thick, the gases will cause it to erupt explosively, creating boulders, cinders, and ash. Some volcanoes have a collapsed central section, called a caldera, that can act like a plug. As the magma flows elsewhere, the caldera may sink until it cracks and the magma has a new path to the surface. Then the volcano can literally blow its top.
Special thanks. Special thanks to my sister and grandmom for helping me with this project and purchasing all the supplies I needed to complete the experiment.
Hi, my name is Michaela Johnson, and for my science experiment, I decided to do Protect Yourself Against Germs to show people the importance of washing your hands. During 2020, we experienced a virus called coronavirus. Health experts told us the importance of hand washing and staying home when you're sick, when you cough or sneeze, cover your mouth and nose. Some kids may think that germs are bugs, cooties, or other gross stuff. Actually, germs are tiny organisms or living things that can cause a disease. I found out washing your hands for 20 seconds will take all the germs away from your hands, and also can avoid getting sick and spreading germs to others. Germs are found all over the world, in all kinds of places. My mom and I did a home fun science experiment where we saw the importance of hand washing. Purpose. Understand that germs can be spread through unclean hands and that hand washing can prevent the spread of germs. Hypothesis. If you put your hand and pepper in the water, the pepper will stick to your hand. But if you put your hand in the soap first, then the water and pepper will not stick. Materials. Ground black pepper representing germs, bowl, water, and soap. Procedure. Fill the bowl with water and shake pepper on top of water. Dip fingertip directly into bowl with the pepper, watch and observe what will happen. Dip fingertip into the soap and then back into the bowl pepper. Observe what happens next and record. For my presentation, I took a bowl of water and I put pepper in the water to symbolize germs. If you only put your hand in the water and pepper, the germs are still there. But when you put soap on your finger and put it in the water and pepper, the pepper flees. Because the soap kills the germs on your hands, this experiment was useful and significant to teach me the importance of hand washing and also the importance of what happens when you don't wash your hands. These are my sites to gain more understanding of why kids should wash their hands. kidshealth.org, cdc.gov, hand washing. In conclusion, clean hands can save lives. Thank you.
How does kinetic energy work? Kinetic energy. Kinetic energy is the energy of motion from the movement of an object like somebody walking, throwing a ball, something falling from a table, windmills, and even a homemade slingshot car. I decided to do my science fair project with a slingshot car on how potential energy is converted into kinetic energy. First, I had to build the car. I had to make a frame. Then I created the wheels and gluing them to the frame. I had to get some tape and tape a rubber band to the frame of the car. I then continued to build the top of the car. I taped down a pencil on the floor to use as my prep station to attach my cars to see how kinetic energy will work. Purpose. My purpose for doing my project on kinetic energy was to see if all movable things have kinetic energy. Hypothesis. If the movement is strong enough, then it will make objects move faster because the movement will shock the object to make it move fast. Materials: glue, glue stick, masking tape, craft stick, 1½ craft cube, straws, wheels, 1/8 dowels, rubber band, and pencil. Here are the steps that I did to make my car. Results. My results are when I pulled the rubber band back soft, it went slow. Then when I pulled the rubber band back hard, it went very fast. They still went the same distance. So when it started out as potential energy and finished as kinetic energy, no matter what the speed is, it will end with kinetic energy. Conclusion. My conclusion for the formula kinetic energy is that after I pull the rubber band back, the energy has been transferred to the object and the object pulled at a constant speed, and the energy is called kinetic energy. So my hypothesis was correct. The movement will shock the object to make it move fast.
The Effects of Dry Ice on Different Fruits by B.F. and K.E. I chose this project because we all wonder what happens when you touch dry ice. Well, we all know you can't touch it, so why not use fruit instead? In your mind, you might think maybe the fruit would just freeze together, stick, and explode. My hypothesis. I think the fruit will freeze depending on the fruit. It will have a different consistency. Materials. You will need dry ice, fruits, a bowl, a plate or solid covering, gloves, a mask or face covering, and eye covering. Step 1. Find fruits such as strawberries, bananas, avocados, etc. Step 2. Find dry ice at local markets or stores. Step 3. Make sure you have the proper equipment such as thick gloves, eye protection, the proper clothing, and a mask or face covering. Step 4. Make sure you have the proper area such as a clear desk. If not, take it outside. Step 5. Sanitize your area with Clorox wipes or disinfectant wipes. Step 6. Clean hands and fruit with warm water and soap. Step 7. Put all needed things on the table. Step 8. Ask a parent or guardian to carefully cut up the fruits. Step 9. Place dry ice in a bowl with plate or solid covering on top. Step 10. Place your selected fruit on top of the covering. Once you start visibly seeing it freeze, take a knife and start carefully cutting up the pieces. Step 11. Evaluate the difference in consistencies of the fruits. Step 12. Once you're done, put the dry ice in a bag and put it outside in the garbage. Here are some results from Google. My results. The fruit started to freeze and turn white. Sadly, my hypothesis was incorrect.
Why does the ocean freeze? From a 6th grader at Cornerstone Christian Academy. Again. Abstract. I want to do a project about water. I decided to do a project about the ocean. I wonder why the ocean doesn't freeze. I have been to a few beaches on the East Coast, even in the winter when the temperature is below 32 degrees, but the ocean is still not frozen. I know the ocean has salt in it, which is different from fresh water. I did an experiment to compare how fresh water and salt water freeze differently. I used 3 containers with fresh water, and the other 2 had different amounts of salt. Purpose. I wanted to do an experiment about the ocean because I love the ocean. I love water. I've been on 5 cruises and I like going to the beach. I'm always getting salt water in my mouth, and I want to know more about it. Hypothesis. My hypothesis was that containers 2 and 3 with salt in them were not going to freeze. Research. Fresh water freezes at 32 degrees Fahrenheit. Seawater freezes at about 28.4 degrees Fahrenheit. Sea ice covers almost about 10 million square miles of the Earth. There are 4 main factors that keep the ocean from freezing. Salt. The salt in the ocean lowers its freezing point from 30 degrees Fahrenheit to 28 degrees Fahrenheit. Water is made of tiny molecules that move around a lot. Salt has small particles called ions that surround the water molecules and keep them from sticking together to form ice. Ocean currents, the constant motion of the ocean water helps keep the water molecules from freezing into ice crystals. High volume. The larger the volume of water, the more heat has to be removed in order to freeze it. Earth's internal heat. The Earth has its own internal heat source. Most of the Earth's internal heat escapes into the oceans. The temperature of the water deep in the ocean is much warmer because of internal heat. The salt, the ocean currents, high volume, and internal heating keeps most of the ocean in liquid form even during cold winters. Producer. We need 3 containers. Label the containers 1 to 3. Have 4 cups of water. Pour the water into cup 1. Pour 4 more cups of water into container 2. Pour 4 more cups of water into container 3. Add 1 tablespoon of salt into container 2 and stir it slowly until it's dissolved. Add 2 tablespoons of salt into container 3 and stir it until it is dissolved. Leave all 3 containers in the freezer overnight. Check to see if all the containers are frozen. And the last one, record the results. Materials: 3 containers, 3 tablespoons of salt, 12 cups of water, a spoon, a marker, 3 labels, and tape. Day 1 of results. 4 p.m. I put all 3 containers in the freezer at 4 o'clock. 9 p.m. I checked all of them in container 1 with the fresh water, which was a solid. Containers 2 and 3 both had a little bit of ice on the top, but my fingers went right through it. There was still lots of water on the bottom. Day 2 of results. 9:30 a.m. in the morning, I took out all 3 containers from the freezer. Container 1 was still frozen solid. Container 2 was frozen, but it still had some water at the bottom. Container 3 that had the most salt was frozen on top, but had the most water at the bottom out of all 3 containers. Here's some results about container 1 to 3. Container 1 had no salt. Container 3, 1 tablespoon of salt. And container 3, 2 tablespoons of salt. In conclusion, after filling 3 bowls with salt and water, I can tell you fresh water can freeze and salt water cannot freeze. Bibliography. I got the information from mentalfloss.com, education.com, oceanservice.com, and oceanservice.com.
My project will be what food will mold the fastest, and I'm in the 6th grade. My purpose for this project was to learn more about mold. I wanted to learn why certain molds were bad to eat. Lastly, I wanted to understand mold so I won't get sick by eating it on accident. Out of all the foods I tested, strawberries, a tomato, a piece of bread, an orange, and a cup of yogurt, I believe that the tomato will mold first. I believe this because of the gelatinous membrane. It's so moist. Out of all the things I will test, it carries the most moisture. The materials I used were strawberries, half an orange, a slice of bread, half a tomato, half a cup of yogurt, styrofoam bowls, paper clips, and a container with a lid. My abstract. After researching mold, I realized it grows in dark, damp, and warm places. So I placed the strawberries in a plastic container with a lid. I placed the tomato, orange, yogurt in a styrofoam bowl and used another bowl as a lid and sealed them with paper clips. I wet a slice of bread and place it in a Ziploc bag. I checked on it every night at 9 p.m. and documented my progress by journaling and taking pictures. I did this for 7 days and kept them in a container for another week just to see what they would look like. My procedure. Day 1, I set up all the specimens in the containers. They are all fresh and brand new. Day 2, everything was still looking fresh besides the strawberries. The strawberries still smelled good but showed white spots that were mushy. The rest of the food smelled good. Day 3, we were finally getting progress for the other foods. The tomatoes were starting to show signs of little green spots. The oranges were turning green on the skin. Day 4, the strawberries are progressing nicely. There is mold in the container. The mushy white spots from day 2 were getting bigger and growing tiny white fuzzy spots on the top. Inside the orange, it looks like it's dissolving, and on the edges, it's turning brown. The yogurt still smells good and looks the same. The green spots on the tomato are getting larger. The bread still has not progressed. On this day, the bread and yogurt remained undefeated. The rest of the specimens were destroyed. The tomato was covered in green spots and smelled bad. The strawberries sat in a pool of liquid covered in white fuzzy mold. The orange was growing mold from the inside out. And here are my results. My hypothesis was incorrect. Strawberries actually molded faster than any of the other foods I tested. The strawberries molded much faster because they are like sponges. That means when they are wet, they soak up all the moisture, where they're more likely to get mushy faster, causing them to spoil and grow mold. Just know my hypothesis was second place right after the strawberries. Research. Mold is a type of fungus. It can be black, white, orange, green, and purple, and can live anywhere indoors and outdoors. Mold grows best when it's wet, damp, and a warm environment. Good mold is something you can eat, like blue cheese, or something that helps you, like medicine, penicillin. Bad types of mold are allergenic, affect people who have certain allergies or asthma. Pathogenic, capable of causing certain infections or diseases. Toxic, produce mycotoxins, poisonous chemicals that are dangerous to humans. There are over 100,000 different types of mold. Mold start growing in 24 to 48 hours. You can remove mold by painting it or using bleach to clean it. You can remove mold with baking soda and water solution.
What is the best source of renewable energy by KC 6th grade? Purpose: to be aware of what our electricity may look like in the next few years. Hypothesis: I believe wind energy is the best source of renewable energy due to it being cheap. My materials are an electronic device, internet, and any reliable information source like Google or etc., and 5 renewable energy sources. Now, the 5 sources I chose to do this experiment with was solar energy, wind energy, hydro energy, tidal energy, and geothermal energy. The definitions for these words: solar energy, radiant energy emitted by the sun; wind energy, wind generated into kinetic energy; tidal energy, renewable energy powered by the natural rise and fall of ocean tides and currents; hydro energy, energy powered by water in motion; geothermal energy, energy from heat within the earth. Procedure: I found 5 sources of renewable energy. I wrote out the disadvantages and advantages of the sources. The one with the least advantages will be deemed the best source of renewable energy. My experiment: So now I'm going to start off with price. They're all cheaper than fossil fuels, but solar energy is the most expensive out of all of them, since it averages to the price of $12,000. But price isn't as important as how it affects our planet. And the worst is hydro, since it damages wildlife and diminishes the recreational benefits of rivers. The most polluting source of renewable energy is geothermal energy, due to the fact that it can only be used in certain places because of the result of small decay of radioactive particles in the Earth's crust. The least efficient out of the two sources we have left is wind energy. It is the least efficient simply because it has some adverse environmental impact. Results. The result in answer to my science fair question is tidal energy, due to it being the most promising out of the 5 I chose. Conclusion. Was my hypothesis correct? No, it wasn't, since tidal energy is more predictable and sufficient. Was my hypothesis correct? No, it wasn't, since tidal energy was the best out of all of them. And my sources are opene.org, adfinergy.com, and nationalgeographic.com. Thank you for listening.
What substance grows herbs faster? By KG, 6th grade. My abstract. I wanted to do something different that nobody would think to do for a science fair. My purpose. The purpose I did this project was to see what substance would grow thyme, parsley, and rosemary the fastest. My hypothesis. My hypothesis is that it'll grow faster in sand because it has the pH level they need to grow. Because sand's pH level is 7, rosemary's is 6, parsley's is also 6, and thyme is 7. Materials. The materials I used was small cups, a permanent marker to label the cups, and the substances. My substances are clay, sand, rock, cotton, soap, and the herb seeds. The herbs I chose were thyme, rosemary, and parsley. Procedure. So you get the tiny cups and label which seed you're putting in the cup and which substance is going in the cup. Put your substance in the cup, then the seed, and then put it in a box just in case it spills. And then water it, but not to the point where you can see the water. And then you water it every other day. Results. So the parsley and the cotton died because I overwatered it and it didn't have any space to breathe. And so did the thyme one. I overwatered that too. The seeds grew faster in the cotton because the pH level was what it needed more, and because it's made of natural fibers. The sand came in third place after the rocks, though. I think it grew faster because cotton's pH level can be 5 to 8. Conclusion. In conclusion, do not overwater it or it'll die. I will now use cotton to grow my herbs. And these are pictures. So this is the thyme right here that I'm holding onto. And here's also the thyme in this. And this was the time when it was like more older, like when it grew more. And it also grew more in the rocks. This is the parsley, and this was the rosemary seeds. The rosemary did not grow yet, like at all, for some reason. And that's it.
Does It Bounce by Kiara Green Woodford. Materials are cups or glass, vinegar, and egg. Steps you'll need. First, put the egg in a glass or cup. Second, add the vinegar. Third, wait 24 hours. When 24 hours are up, check to see if the egg is foaming. Fourth, when the egg is swollen and rubbed against the walls of the cup or glass, take it out and wash it off. Last, bounce the egg. Hypothesis. I think the egg will break from a far distance. And here's a video of me bouncing the egg. And here are some more pictures.
Wait, I ain't pulled this in yet. Half a cup of vinegar. Wait. All right. Go ahead. All right. And 1/4 cup of vinegar.
Hello, my name is Deandre, and this is my science project. My scientific question: out of Sprite and Cola, which will go higher if I added Mentos? My purpose: the purpose why I did this project to see which soda can go higher because I want people to watch their diet. Because the higher the soda went, the more sodium and calories and carbs, and you get bigger. So that's why I did this project. My hypothesis. My hypothesis is Sprite will go higher because the carb and sodium are high, and you get an instant reaction when you drink Sprite. When I talk about instant reaction, I'm talking about burp or the sniff through your nose. Materials. The materials I use is Coca-Cola, Sprite, Mentos, and a table and a bucket. My procedure. I hope you enjoyed this video. Hello, this is my procedure. The first thing before you need to do for my procedure, you need a table. Then you're going to need a bucket. Then you're going to need Mentos. And third, and lastly of all, you're going to need Sprite and Coke. Because then I put it in here. You shake it. See that? You shake it. Then you go to the next one. Then I'm going to open up the Mentos. Then I'm going to open up the Mentos for the Sprite. Now let's see what it would do for the Sprite. Will it go high or will it won't be a bust? That's very hot. That's very good. Now we're going to do Pepsi. My result. Coca-Cola went the highest out of Sprite. The Sprite had a quicker reaction but only rose to an inch. However, the Coca-Cola had a slower reaction and it rose higher than Sprite. My conclusion. I asked which soda would explode the highest. I said Sprite. Because the carb and the sodium was very high, but I was wrong. Even though the cola was slower, it went higher. So I answered my question. The Coca-Cola was higher. Here's my graph and chart. Okay, now if you look very closely on here, it says Coke went about 1 millimeter. And you look here, it says Sprite went about 1.5 millimeters. My abstract. I wanted to investigate which soda would explode the highest after I put full Mentos into it. For my hypothesis, I believe that Sprite will because the carb and sodium are very high. I chose these soda because everyone likes them. I chose this project because it gets me something to do since COVID, and it's like an engineer project because engineer studies math, the width and length. Also, it will be fun because I never did anything like this. My acknowledgement. I want to acknowledge my family because I was going to do a survey on my blog on which soda would explode the highest. Because COVID, I had to change plans. Then my uncle just said, do the survey on the family. And I did. I have 10 people in my house. So 9 of them said Sprite would explode the highest. One of them said Coca-Cola. And here's pictures of Sprite. I hope you enjoy. And here's picture of Coca-Cola. And my bibliography I got from Google, Wikipedia, and YouTube. I hope you're having a nice day.
Science fair project. Question and purpose. Our question was under what circumstances is the sky blue? The reason we chose the topic was because we always knew the sky was blue, but why? Hypothesis. Our hypothesis was that it was bright blue when it was sunny outside. Research. We found out that sunlight reaches Earth's atmosphere and is scattered in all directions by all gases and particles in the air. Blue light is scattered more than the other colors because it travels at shorter and smaller waves. This is why we see a blue sky most of the time. We also found out that these shorter wavelengths correspond to blue hues, because when we look at the sky, we see blue. We see it as blue. We were right about our hypothesis that when it's sunny, the sky is bright blue. Materials and procedure. The materials we used was nothing but our eyes. The procedure was first we would wake up and look at the sky. Second thing we did was look at the sky throughout the day and take notes whenever. Thirdly, we would research different things about the sky and how it works. Lastly, we would record all of our findings each day in our logbook. Results. It was sunny 90% of the time, and when it was sunny, it was a bright blue. It rained 5% of the time, and it was still blue, but not as bright. It snowed 5% of the time, and when it snowed, the sky was more whitish. Data chart. Sun 90%, rain 5%, snow 5%. Conclusion. In the amount of time we had to do this project, the conditions for it to be a bright blue is for it to be sunny. When it rained, it was like a dense blue. When it was snowing, it was more whitish. Bibliography and acknowledgments. We'll use the internet and Google and write a book about it. Acknowledgments goes to moms because they helped us in every step of the way. Done.
This is my science fair project. My name is Deandre, and I hope you enjoy. My experiment. My experiment is to see how the sunlight affects plants and their photosynthesis. I put one plant under a lamp, one in the basement, and the last one outside. I wanted to see how each one would grow and what would be the outcome of this experiment. The steps. My steps are like what you would do with any other plant if you were trying to grow them. Make sure the soil is flat and of good enough quality. Make sure the seeds have enough space. Water them and give them enough sunlight. Well, for two. And put the other one in the basement, and since light shines through one of the small windows, I put it behind something where we get little to no light. What I did. This part was kind of like the steps, but showing what I did during this time. Since the pots were different sizes, I gave the smaller one quarter of a cup of water. The other two were bigger, so I gave them half a cup of water. I planted the marigold flowers and a mix of other flowers in the other two. In the project for experiment 1. Progress. The first one I planted was outside. I left it outside exposed to the elements for months. On the day I planted it, it was raining outside, and it was in early February. During that month, there was a lot of snow. Then, on the day I checked on it, to my surprise, it was still growing despite being out in the cold and in the snow for so long. It started to grow. This is all that it grew in the picture on to the left. If you need to look, if you look closely, you can see a bit of green in the photo. An experiment 2 took place in my basement. I left it down there, watering it every week. For the first few months, I left it behind to sort of mat or something, but it was still getting a bit of sun and moonlight. Therefore, it still grew a bit. Now I moved it to into a more dark area, which it got little to no sunlight. In the end, they ended up dying. Progress for experiment 3. This one was left under a lamp. This one grew the best out of the other two. I watered it the same as the one that was in the basement, except I gave it less water because it was in a smaller pot. Since it got light almost every day, it grew to very impressive lengths shown in the picture to the left. My hope. This project would not be possible without my mother, otherwise I wouldn't have be able to get the materials to start this project. My conclusion. Oh, wait, no. My inspiration. I didn't really think it was an inspiration. It was more of like I was just interested. Anyways, I thought it'd be interesting to try something out like this. I even have more questions on what happens internally, like the cells and stuff. My conclusion. Now, I forgot to put my hypothesis and the materials. And yeah, so my hypothesis was that the one outside would grow a bit better than the ones inside my house, and that the one in the basement would be the one that grew the least out of the two. But my hypothesis was wrong, since the one, well, counting that it didn't die, not counting that it died, it technically grew better than the one outside, and even though like it was in the basement and stuff, it still got like a bit of light. The only reason why it died was because I moved it to like a little more of a little place, and my materials were good quality soil, 3 pots, and some seeds. Were marigold flower seeds, and the other seeds were just a mix of other flowers. And yeah, for my conclusion, my hypothesis was wrong. The one under the lamp grew the best, and the one outside grew the worst, and the one in the basement was like middle ground. So yeah, that's all for my project, and I hope you have a blessed day.
How does coffee affect the alertness of the human brain? By Haley Paris, date March 14th, 2021, class science, teacher Miss Grant. Abstract. The central nervous system is made up of the brain and spinal cord. The peripheral nervous system is made up of the nerves that branch off from the spinal cord and extend to all parts of the body. The central nervous system, CNS, controls most functions of the body and mind. It consists of 2 parts, the brain and the spinal cord. The brain is the center of our thoughts, the interpreter of our external environment, and the origin of control over body movements. Caffeine is a natural stimulant. Its main effect is on the central nervous system, where it can increase alertness and provide a needed boost when you are tired. Caffeine's effects peak within an hour after consumption, and the body eliminates half of it within about 4 to 6 hours. Caffeine acts as a central nervous system stimulant. When it reaches your brain, the most noticeable effects is alertness. You'll feel more awake and less tired, so it's a common ingredient in medications to treat or manage drowsiness, headaches, and migraines. Purpose. There are people who say caffeine wakes you up and makes you alert. There are some people who say that it doesn't. This experiment was conducted to see if caffeine really does help you with alertness. Question. How does caffeine affect alertness in the human brain? Hypothesis. During this experiment, my predictions were that the person who drank the decaf black coffee wouldn't be as alert as the person who drank the regular black coffee. Materials. Decaf black coffee, regular black coffee, 2 8-ounce cups, blood pressure cuff, operation game. Procedures. I took both subjects' blood pressures. I gave both subjects coffee. They both waited an hour before playing another round of the operation game. I took their blood pressures again before they played the game. I recorded how many misses both subjects made during both rounds. Experiment. I took Subject 1 and Subject 2's blood pressure. Subject 1 and Subject 2 played 1 round of the operation game. I recorded how many misses both Subject 1 and Subject 2 made. Subject 1 drank 8 ounces of regular black coffee, and Subject 2 drank 8 ounces of decaf black coffee. I took both of their blood pressures and waited 1 hour before playing another round of the operation game. I recorded how many misses were made during the second round of the operation game. Subject 1 had 17 misses the first round and 5 misses the second round. Subject 2 had 20 misses the first round and 10 misses the second round. Subject 1's blood pressure was 118/75 and 83 pulse before the coffee, then was 130/83 and 82 pulse after the coffee. Subject 2's blood pressure was 124/58 and 75 pulse before the coffee, then was 128/63 and 70 pulse after the coffee. Conclusion. My hypothesis was 100% correct. Subject 1 was more alert during game 2, and Subject 2 was alert but not as much as Subject 1 after drinking the coffee. Bibliography.
How does color affect eyesight? Created by A.G., 7th grade. The purpose. I picked this project because I thought this would be interesting. I also thought this would be fun. I wanted to do an experiment that I never tried before. I just thought it would be cool to see what makes the natural eyesight weaker or stronger. Hypothesis. I think the eye charts that have lighter inks would be the ones with the most errors. Materials. Pack of markers, a pack of 5 poster boards, tape, test subjects. One test subject is a female. They are 32 years old. The other test subject is a male and is 9 years old. Procedure. Number 1, I got all my test subjects. Number 2, then I made the original black eye chart. Number 3, I made different eye charts with red ink, pink ink, and yellow ink. I told the test subjects to move 6 feet away from the eye chart. After I observed the errors that each test subject made on each eye chart, I scored each errors for each eye chart. Results. The errors made on each eye chart. Black ink, 5 errors. Red ink, 4 errors. Pink ink, 6 errors. Yellow ink, the test subjects could not see from the 4th row down. Since they could not see the 4th row down, I will not count it as an error. Both test subjects said that the yellow ink was too bright, which made it unable for them to read the 4th row and below. Conclusion. My conclusion is the bolder and darker colors are easier to see, and the brighter and lighter colors are harder to see. Acknowledgements. I am saying thank you to my mom and my brother for participating in my experiment. I am saying thank you to my mom for buying my materials and proofreading my science fair project. Thank you for listening.
How smart are you? How much of the brain do we use? According to a survey in 2013, around 65% of Americans believe that we only use 10% of our brain. But this is just a myth. According to an interview with an archaeologist, Barton Garden in Scientific American, he explained that we use majority of the brain and is always active. Hypothesis and procedure. If your brain uses 10% of it, are you able to use more? 1. Figure out why we only use 10% of our brain. Figure out what is 90% of our brain doing. Figure out if we can use more. Figure out how to use 10% of our brain. Interview people and see if they make it higher than 10%. Materials. Pen, pencil, notebook, people from different ages, brain teasing video and activities, and play cards. Research and data. I researched that the notion that a person uses only 10% of their brain may be a myth. fMRI scans show that we will need more than 10% of our brain to do activities. While there is still a lot to learn about the brain, researchers continue to fill the gaps between fact and function. If 90% of our brain were completely unused, then that portion would degenerate significantly. But the brain scans of a healthy person reveals all parts to be intact. All this research added up to the same exact thing, which is using 10% of your brain is a myth. So I changed the hypothesis that helped with everything. If we use 10% of our brain, can we focus and remember things at once. The first relatable question that I came up with was, can we focus on multiple things at once? See if people can recognize different surroundings from seeing it one time. Remembering things in details from something we see every day. Test. I asked the 14-year-old questions and test their awareness as shown in this video. In the other slides are me showing a 27, 34, 50-year-old a brain-teasing test. You may participate in these activities. During the video, I was proving that although there was distraction, some can be helpful instead of putting your focus somewhere else. Test 2.
What does jumping rope have to do with the brain? Well, double Dutch requires off-the-chart spatial awareness. Today, these kids are going to help us test yours. For this game, all you have to do is keep track of the number of times that either of the girls in green jumps. You'll count each time one of them lands a jump, like this. 1, 2, 3, 4, 5. As you can see, these jumpers are pretty quick on their feet, so you're going to have to pay attention to keep up. When the whistle blows, start counting. Ready? Go. So, how many jumps did the green team make? Did you say 38? If so, you agreed with 40% of our test audience. Now, some of you may be onto us, but for those of you who aren't, did you happen to notice anything else going on during the double dutch? Maybe a giant chicken strolling right through the middle of the set and doing a funky chicken dance? Now, some of you may have missed that funky chicken, but many of you probably saw it, and that's okay, because the chicken was just there to distract you too. Here's the real question. What color was the wall behind the double dutch game? Here's a hint. It wasn't the same color at the end as it was when they started jumping. The back wall was changing color the entire time, from bright blue to bright red. Nearly everyone misses it. But why? It turns out there's far too much information coming in through the eyes at any given moment for the brain to fully process all. As a result, the brain has to act like a spotlight, focusing our attention on some parts of the scene but not others. Now, most of you were probably paying attention to the jumpers, and some of you may have suspected that something strange was going to happen, so you saw the chicken. But you probably weren't paying attention to the back wall. And what we don't pay attention to, we don't see. And, hey, for those of you who managed to catch everything so far, did you notice that we also swapped the rope turners out halfway through? Gotcha.
The 27-year-old was able to catch everything except the background. The 34-year-old was able to keep count of the green players and see the chicken. They didn't realize that the players were switched out or the background. However, the 50-year-old was able to keep count but not able to see the chicken, the switch, or background change. Test 3.
How many passes does the team in white make? The answer is 13. But did you see the moonwalking bear?
The 27-year-old was able to keep count. However, they saw the bear but just thought it was a play on a black teen. Although the 34-year-old and the 50-year-old was not. Oopsie daisy. Oh, okay. Test 4.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master's bedroom.
I was buttering his lordship's scones below stairs, sir.
I was flaunting my petunias in the potting shed. Constable, arrest Lady Smythe. How did you know? Madam, as any horticulturist will tell you, one does not plant petunias until May is out. It's just a matter of observation. The real question is, how observant were you? Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
But I was planting my petunias in the potting shed. Constable, arrest Lady Smythe.
This was very hard. Nobody was able to see the changes, but was very surprised to see the difference behind the scenes. My hypothesis was wrong. Due to my test, we can only focus on one thing at a time. We use 100% of our brain, but it will only work on one thing at a time. The myth that we only use 10% of our brain may be true because this is our focus leader. When I say focus leader, I mean our eyes, which falls in on focusing on one thing. Our eyes are technically one. And look at one thing, which is why we can only look/focus on one thing. While we are focusing on one thing, our brain is putting the input on that object or subject. Thank you for listening to my presentation.
Does temperature of the environment affect the activity level of a snail? By Nicholas Jackett. Purpose. The purpose of me doing this project was to see how animals live and under what temperatures do they have to be in to live and stay healthy. I always wanted to do a project on animals without killing or harming them. This year I decided to work with snails. Note, animals in this experiment were not injured or killed. Make sure if you try this at home, you have everything you need to take care of them. Additional information will be provided at the end of this presentation. Hypothesis. Does temperature of the environment affect the activity level of a snail? My hypothesis is that if the temperature is just about 70 degrees Fahrenheit, the snails will be most active in this stage. I say this because that is the temperature where humans and dogs are most active in outside. Materials. Logbook. 2 or more palmetilla snails carried to lettuce that can feed them for at least a month or 2. Soil, a place with sunlight. Thermometer, a place where you can slowly change the temperature. Water, container or glass container with over 10 holes on top. Procedure. Step 1. Get snails, feed them early in the morning. Step 2. Place them in the temperature of 77 degrees Fahrenheit. Mark in logbook how their activity is. Maybe record a part of them moving and playing. Remove snails from 77 degrees Fahrenheit and then put them in 55 to 60 degrees Fahrenheit. Step 6. Feed. Watch and record how their activity level is. Mark in logbook. Repeat steps 1 through 7 to see if there are any variables that change over time. Tell whether your hypothesis is correct. And this is a short video with like a 5 to 10 day check-in. Here we go.
Hello, today is day 3 of my science fair project, and my snails are in the 77 to 80 temperature, and they are very active. Yes, they're active and they're eating very well, and you will see one of them crawling in the next clip. Thank you. Hello everyone, today is day 1 with the snails in the 55 to 65 temperature, and they are very active down here. It's kind of chilly, but it seems like they're liking it for now, but you never know, things could always change. Hello everyone, it is March 1st, and my snails, they are, again, very active, but they're not eating. That's weird, they're not eating. But real quick, they're mostly climbing the walls, and that's pretty it. I tried to change up the food to see if the food was making them not eat. They love carrots. I put carrots in there. The carrots have not been, I didn't see any bite marks in the carrots. Then I switched up to some apples, and I'm going to try some lettuce and maybe strawberries next. Hello, today is March 10th, and sorry about my dogs in the background. So I put some strawberries and some lettuce inside of the snails' their habitat, and it looks like they are not eating. They have, I looked, and the food has not been ate, or I have not seen any bite marks. And 2 days now, so I'm starting to think that certain activities with the snails depend on the temperature. Others do not. Okay, so as you can see, this snail is not sleeping, not eating, but it is moving. Very active today. Hello everyone, today is March 10th, and this is another progress video with my snails, and it looks like that, well, I'm not going to show you now, but in my next clip, you're going to see one of my snails. They're being very active today, so this adds some points on whether the snail's temperature affects its activity level. Stay tuned for the next video. Here is some footage of one of the snails eating. The temperature is 55, well, 54 to be exact. This snail has just woke up from a nap, and it eats, and most likely will go back to sleep. Okay. Hello. Wait. Oh, it's recording. Okay. Today is day 12 of my science fair project. It is the last and final day. And my snails have now been in the temperature around 55 to 60 degrees Fahrenheit. They have been not very much active, unfortunately, but they were active. They were not as active as they were in the 77 area, which means that my hypothesis was correct. My snails, so in this temperature 55 to 60, they were mostly sleeping and eating. So after they went to sleep, they would eat. They would just move around a little bit to see if there was sun or any warm temperature. But since there was not, he would go back to sleep. I have one in my hands. He was, or she, whatever they are, was just sleeping. And now he or she is awake because I just touched them or whatever. But yeah. So my hypothesis was correct. And yep, that concludes the end of my science fair project.
All right, and we are back. In conclusion, my hypothesis was correct. The snails were more active in warmer temperatures. Snails originate from mostly desert or deep sea area, so the temperature of their environment is very important. The snails were very active and eating in the 77 degrees Fahrenheit temperatures. They were only moving around and not eating in the colder weather. Bibliography and acknowledgement. Science Lord Prentice Hall, Life Science Textbook. I thank everyone in their respectful places. And that concludes that. Thank you.
My project, I did pineapples. Specifically, the pineapple enzymes on what's inside. And this is when pineapples fight back. Myself, Fred Jackson. For my project, I wanted to know why pineapples leave a tingling feeling in your mouth when you eat them. What I did was I gathered 3 people and had them eat 3 slices of pineapple. I asked them to tell me when they started to feel that tingling feeling. While they ate, I did some research on pineapples, specifically what's inside. I didn't go to a library since I lived nowhere near one and everyone was too busy to take me, so I had to rely solely on the internet. I thought pineapples did this for defense, but I was wrong. It turns out they have an enzyme called bromelain, which breaks down proteins. This is also the reason pineapples won't form into jam and jelly. When gelatin is used, the enzyme breaks down the gelatin. This was a pretty fun project to do, hearing all the things people had to say. Purpose. I chose this topic because whenever my mom or grandma ate pineapples, they would always say it left a tingling feeling. I don't eat pineapples, so I had to trust what they were saying. I asked people what pineapples taste like, and they all said sweet, but it burns. I always wondered why they would say it burns, but I never actually ate one. This project helped me better understand what pineapples are. Hypothesis. I thought the reason pineapples left a tingling / burning feeling was for defense, but when something would take a bite out of it, its mouth would burn or feel weird and it would know not to eat it again. My materials, I needed a knife, 3 pineapples, and I needed 3 people. Procedure. Buy a pineapple, wait for it to ripen, get 3 people, cut the pineapple into 9 slices, give each participant 3. While they eat it, you do the research. Have them eat each slice and then tell you what they feel after each slice. Write down what each participant says. The results. The first slice, my mom said she didn't feel anything, but it tastes good. My dad said he didn't feel anything. My brother said he didn't feel anything. For the second slice, my mom had no reaction. My dad said it felt weird. My brother said it left a tingling feeling that I was talking about. And for the third slice, Mom says she feels it now. My dad said it feels like it's getting stronger. And my brother said he still feels it, but it doesn't affect the taste. I found out that pineapple contains bromelain. Bromelain is an enzyme that breaks down proteins and is used to tenderize meat. It is the enzyme which makes your mouth tingle, burn, and in some cases bleed. Since bromelain breaks down proteins and you have proteins in your mouth, it's trying to break down the proteins in your mouth. So when you eat a pineapple, it's eating you back. This is my bibliography. And my acknowledgement go to my mom, my dad, and my brother.
Hello, my name is Deandre Jones. This is my 7th grade science fair project. My project is on what makes ice melt faster. Slide 2. The materials I used for this project was salt, marker, hot water, cold water, sugar, cups, and ice. My procedure. I started by getting 5 cups. Any size is okay. I added 4 ice cubes into the into the 5 cups. The first cup I added salt. I did about 4 sprinkles of it. The second cup I put sugar and added 3 teaspoons. The third cup was cold water. Fourth cup was standalone, which is room temperature. And the final cup was hot water. Then I took the red marker and marked it. I had a notebook and timed it. Hot water was done in 2 minutes and 30 seconds. Cold water was done in 3 minutes and 38 seconds. Sugar was done in 3 hours, 46 minutes and 3 seconds. Salt was done in 3 hours, 39 minutes and 27 seconds. Room temperature was done in 3 hours, 40 minutes and 12 seconds. That's it. The purpose. I chose this because I thought it would be fun. I tried doing a project, but it failed. The purpose of ice is to heal an injury or cool a beverage. Or for the injury, it numbs the pain and also reduces the swelling. Ice can also be used in your local fast food restaurants. Examples as McDonald's, Chick-fil-A, and Popeyes, and many more. My conclusion. Salt lowers the freezing. Hold on. Move my camera. Conclusion. Salt lowers the freezing / melting point of water - ice. When the salty ice cube was placed in the sun, the lower freezing point combined with I can't really pronounce that word. I can't pronounce that. Sorry about that. But continuous, I'm sorry. Heat from the sun made the ice melt much faster. Sorry about that one word. My question. Would salt melt ice faster than cold water? As you can see right here, these are the time lapse for salt, sugar, and room temperature. Is a time lapse right here. My result. As my theory was correct and incorrect. Salt melts faster than cold water, but when you use the cups, it was pretty short. When it snowed, the salt made it melt way quicker. The hypothesis. The hypothesis for this experiment is that the ice cube containing 3 teaspoons of salt will have a fast melting speed than the ice cube melting with 0 additives. Of granulated salt have a faster melting time than the cube with 0 additives. Thank you all. Thank you for your time. This project roughly took almost 4 days to complete. I hope everyone enjoyed. Thank you.
This is my science fair project. Which wavelengths of light most effectively produces chlorophyll for photosynthesis? My purpose. Since in class we went over photosynthesis, it piqued my interest, and also as a kid, I just knew that oxygen came from plants. But how does it happen? Hypothesis. The blue light will be absorbed by the plants and photosynthesis will come faster than green light because green has a low light absorption from about 500 to 600 nanometers, but blue peaks around 450 to 475. The color that is reflected cannot be absorbed. Colors such as green/yellow. Variables. Independent variables is light wavelength. The dependent is time. The controlled is the number of spinach discs, the temperature and concentration of sodium bicarbonate. The materials are a stopwatch, colored LED lights, syringe, 2 grams of sodium bicarbonate, 100 milliliters of distilled water, 500 milliliter beaker, 3 spinach leaves, a hole puncher. Procedure. Mix 2 grams of sodium bicarbonate into 100 milliliter of distilled water to create a 2% sodium bicarbonate solution. Punch 10 spinach discs out of 1 spinach leaf and place those into a syringe. Place the syringe on top, then place the syringe into the sodium bicarbonate. Pull back the syringe to fill the syringe with 10 milliliters of sodium bicarbonate. Then holding the syringe with the tip facing the ground, lightly pull the plunger up, then slightly push the plunger down to remove the oxygen from the leaf. Place the syringe in a 50 milliliter beaker, then in a dark room. Put color LED lights, any color of your choice. I did blue and green. These are the graphs and the pictures from the experiment, and what is happening in the graphs in the experiment will be explained in the next slide. Data. Blue light. 7 of the 10 discs in the blue light beaker rose to the top of the syringe within 15 to 50 minutes. The first 4 rose in 15 minutes, then 1 more at the 20-minute mark. The last 2 rose up at the 30 to 50-minute mark. The green light. None rose to the top in the green beaker. This project can be done in 1 day. I did this project in an hour. And if you want to go deeper into the thing, you can do it for multiple days. The conclusion. After I conducted my experiment, I discovered my hypothesis was correct, that blue light will be absorbed in photosynthesis at a faster rate than green light, because green has a low absorption rate from about 500 to 600 nanometers, and blue peaks at 450 to 475. The color that is reflected cannot be absorbed. These are all the sources, and below is the logbook, which includes more information about the project. And that is the science fair project.
Hi, my name is Aaron Chamberlain. I am in the 7th grade. My science fair project is on viruses versus bacteria. My purpose for doing this experiment. I chose this project because I wanted to do something relatable. And when I say relatable, I mean a project that has something to do with what we're going through. So I looked in my textbook and saw a topic on viruses and bacteria, and I became interested in that topic and decided to do that. And also to give some information to people who are confused about the virus and how you could prevent from having bacteria on you, especially during this time, and because of the global pandemic we are now facing. So I thought this would be a good topic to talk about. My hypothesis. My question. What is the difference between a virus and bacteria, and which has the most effect on a human? I think that a virus has the most effect on a human because most viruses cannot be cured. And I say this because bacteria can be treated and gone, but most viruses can be treated but still be in the atmosphere. And my hypothesis with my experiment is that the virus will turn the human body fully purple, and with the bacteria, it will slightly turn the water yellow, but not as much as the purple water. My materials for my science fair project. I used 3 clear plastic containers, sticky notes, Sharpies, water, and colored dye. My procedure. The first step I did to start my experiment. I gathered all my materials I needed to succeed in this project. After I got my materials, I put sticky notes on each one of the containers. One container said human body, the other said virus, and the last one said bacteria. In each of these 3 containers, they all had different colored water, which represented the bacteria, virus, and the human body. After I labeled the containers and put the colors in the water, I then started to mix the water and the colors. The human body was clear water, the virus was purple, and the bacteria was yellow. My second procedure. This is what happened when I poured the purple, which is the virus, and the clear water, which is the human body, and this is what happened. This shows how a virus affects the human body. My third procedure. This is what happened when I added the yellow water, which is the bacteria, to the clear water, which is the human body. This represents how it affects the human body. And as you can see, the yellow, which is the bacteria, does not have the most effect on the human body as a virus does. This is the before picture and this is the after picture. My result. Well, since my science experiment could be done in 1 day, everything that happened was the watercolors mixed and showed what effect bacteria and the virus had on the human body. and my experiment showed that a virus has the most effect on the human body, and the result is that the bacteria is not as dark as the virus, which is showing that a virus has the most effect, and the result was accurate to my hypothesis. And these pictures right here are the final results of my experiment and how they came out. My conclusion. I found out that my hypothesis was correct and that a virus does have the most effect on the human body, and that you can control and prevent from having bacteria on your hands. But with a virus, it comes through many different parts of your body without you even knowing. This link right here are the links to my formal report and my logbook. I really hope you enjoyed my presentation and have a nice day.
Bouncy Egg Science Experiment by Ariana, 8th grade. Question. Can pitting the egg in vinegar make it bounce? The experiment. Materials. 1 raw egg, vinegar, in a glass jar. I use a mason jar, but you use any jar or any glass. Just make sure that you can see through so you can make some observations. Procedures. Get a raw egg, carefully place it into a glass jar or a glass or a jar, then fill the glass with white vinegar until the egg is completely submerged. Leave the egg in the glass for 3 to 5 days. Each day, check back on the egg, make some observations. Carefully remove the egg from the glass and rinse it under some tap water. While rinsing it, gently rub the outside of the egg and the white film will come off, leaving you with a translucent egg. Over a plate or other container or bowl, anything. Lift the egg 1 or 2 inches in the air, let go, and watch it bounce. Hypothesis. My hypothesis is yes, vinegar can make an egg bounce if you leave the egg in a vinegar for the right amount of days. Then it shall most likely work. Hypothesis support. I think this was going to happen because the egg becomes bouncy as a result of chemical reaction between the eggshell and the vinegar. The eggshell has calcium carbonate, and the acetic acid divides the eggshell from the egg, allowing the shell soluble in the vinegar. Results. Pictures and observations. This is the raw egg before I put it in a jar, put anything on it. And this is after it. After the whole 5 days, I rinsed it off and stuff. And yeah. Day 1, which was Wednesday. It was about 20 to 30 minutes after I put the egg in the vinegar, and the egg had bubbles around it already. Then about an hour and a couple minutes later, the egg had bubbles around it still, but it had foam at the top. Day 2, which was Thursday, at 9:06 in the morning, the egg still had bubbles around it with foam at the top, but if you look close, you can see that it was starting to crack. This is the picture right there for 9:06 in the morning. At 11:44 a.m., the egg shell was on its way coming off a little, and you can see the yolk inside, which is right there. Oh, right here. I'm sorry, which is right there, and it you can kind of see it a little bit. Then at 7:31 p.m., the egg still had bubbles around it, but this time you could really see the yolk. So this is the foam that was at top, and then it still had bubbles around it. You can see that it was cracking a little bit. Day 3, which is Friday, at 9:17 a.m., the foam that was at the top had moved to the sides of the jar, and there were still bubbles all around the egg, but the egg was clear. you could see that the egg was getting clear, and you could see the yolk a little. So right there, you kind of see the yolk. Day 4, which was Saturday. At 12:41 p.m., the foam that was at the top of the jar had disappeared, and the egg still had bubbles around it. So you see, there was no more foam, but you could see the bubbles. Day 5, which was my last day, Sunday. At 12 p.m. I took the egg out of the jar and rinsed it in water. Then when I was done on the outside of the egg, it was rubber, and on the inside, if you put it up to a light, you can see the yolk in the inside. So this one I put up to a light, and you kind of see the yolk a little right there. And then there's just another picture of me with it. And yeah, it was rubber outside. So I don't know if you can't tell, but yeah, it was rubber outside of. Here's a video of me seeing if the egg was really what it said it was about. See if it was really one bounce. First take, second take, and three. And that was three. When it bust, that was 3 inches higher than. It was higher. It was a little higher. Conclusion. My results conclude that my hypothesis was correct. Vinegar can make an egg bounce. But what I found out is that vinegar can make an egg bounce, but when I tried to lift the egg up 1 inch more from the plate, it bust, which y'all saw in the video. Thank y'all for listening to my project. Hope you have a safe and good day.
Good evening, Cornerstone judges. Today I will be presenting my science project. My first slide is, in what way can you blow a balloon without using air? This is my question. Purpose. My purpose for doing this experiment is to show that simple experiments like this can still be educational and fun. I also did this project so I could be a good example for my cousin who first suggested I do this project. Lastly, I did this experiment because it was fun to do. Abstract. On January 25th, 2021, at roughly 7 p.m., I did my first test of my experiment. During my first trial, I didn't use any exact measurements and winged it. It ended up being a complete fail, but I didn't stop there. I continuously tried to do the experiment without exact measurements by learning from the before test. In the end, I came to the conclusion this won't work and decided to watch a YouTube video as an example. Even while watching the video, it did not show the exact measurements, so I did the only thing available, look up the experiment. I then tried to follow the steps as closely as I could. The experiment required a funnel, which at the time I did not have. I got a paper towel, rolled it into a funnel shape, and poured baking soda in the balloon. For the vinegar, I had already poured it into a 2-liter bottle. Lastly, I took the balloon, stretched it over the top of the bottle, and shook the baking soda out. Hypothesis. If you use baking soda and vinegar and mix them together, then it will inflate the balloon because when mixed, baking soda and vinegar release carbon dioxide. Materials you will need for this project is 1 cup pure white vinegar, a 2-liter bottle, balloon, 1/4 cup baking soda, funnel, rag, optional, measuring cup. Procedure. Take a 2-liter bottle. Step 1. Take a 2-liter bottle and fill it with 1 cup of pure white vinegar using the measuring cup. Step 2. Take your balloon and using a funnel, pour 1/4 cup of baking soda into it. Step 3. Wrap the top part of the balloon around the tip of the bottle, making sure not to flip the balloon around. Step 4. Make sure the neck of the balloon is not twisted and shake the baking soda out. Then shake the bottle to make sure it mixes well. Step 5. Using a rag, clean up any spilled baking soda or vinegar. Data. What I observed was that when the baking soda and vinegar mixed together, it made fizz, like soda does when you open it. I then found out that CO2, carbon dioxide, is packed tightly in the cans, up to 1,200 pounds per square inch. So baking soda and vinegar blowing up a balloon would be the same as opening a can of soda. Conclusion. In conclusion, my hypothesis was correct, since carbon dioxide was produced, just like it would be if you were to blow it up yourself. It was also a success because although it was a bumpy start, after fully making observations, improvising, and some help from my uncle, it all came together. Bibliography. My bibliography contains the video which I watched for my abstract, the link for which I used to follow the instructions when I looked at my project, and the template I'm using now for my project. Thank you, and have a good rest of the day.
Hello everybody, and today we'll be doing the water vacuum project. My name is David Armstrong, and let's get this going. So, the materials you need is rubber bands, candles, food coloring is optional, you can use any color you want also, a glass or a see-through cup, and a lighter. Now the first thing you want to do is wrap the rubber bands around the candles and make sure the candle stands. Now I use 12 candles because I want a bigger reaction, but you can use any amount of candles you want. I already stirred the food coloring in with the water. I used about under 32 ounces of water, so it looks like it's somewhat at 16. Now, what you want to do is turn the lighter on. Be careful. And light the candles up. Now it's all lighting up. Now the next thing you want to do, this is going to be awesome. The next thing you want to do is put the glass over the candle. And look at that. It sucked in most of the water. Now, if I try to pick it up, it won't move. The reason why is there's a vacuum that happens when the fire has no more oxygen. So when I put the glass over the candles, the oxygen completely disbanded, as in there was no more oxygen for the fire, so that's why the water came up into the glass. And that's all, guys. Have a great day, and God bless. Alright, hey guys, this is take 2 of the water vacuum project. As you can see, on the first try, we had more water, and we're going to try it with less water. So, let's get it going. Make sure you're very cautious with the lighter, because you could get burned really easily. And when I tell you when you can get burned really easily, you can get burned really easily. Now let's do this. Same outcome. It sucked up the water and ain't moving. The amount of suction on here is really strong. And that's for take 2. We use less water, and I can see that most of the water is being actually sucked up this time, and it's pretty good, in my opinion. And that's it. God bless. Have a great day.
Hi, my name is Jay Breed, and this is my 8th grade science fair project. Today I'll be showing you how to conduct your own fingerprint analysis. Purpose. The purpose of this project is to see if my fingerprints are all the same, or to see if they are all different. From the naked eye, I don't see any difference in my fingerprints, but let's see if there is. Question. How to conduct your own fingerprint analysis. Hypothesis. If I conduct my own fingerprint analysis, then I will be able to compare the difference in my other fingers, because not all of my fingers have the same print. Introduction to conducting your own fingerprint. We touch things every day. A coffee cup, a car door, a computer keyboard. Each time we do, we leave a track of DNA called fingerprints. Everyone has different fingerprints. Even identical twins with identical DNA have different fingerprints. There are many sorts of fingerprint patterns. They come in all different shapes and sizes. This uniqueness allows fingerprints to be used in all sorts of ways, including for background checks, biometric security, mass disaster identification, and of course in criminal situations. Materials. You will need fingerprint cards, second, an ink pad, third, a fingerprint holder, and 4, a lupe. For the fingerprint cards, you'll need an official blue lining FD-258. For the ink pad, you need an official black ink fingerprint pad Easy Print EP15. And the fingerprint holder is used to hold the fingerprint cards in place. And the lupe magnifier is used to analyze the fingerprints. 2 useful materials are baby wipes and retabs for if you need replace mistaken prints. Procedures. First, take your fingerprint card and put it in the holder, which is the fingerprint card holder. Then close the lid to the first 5 blocks on your card. Second, the first row is where your 5 fingers are going to go. Third, open your ink pad up and get an even amount of ink on it. Fourth, hold your holder, start on your right side of your finger and roll your thumb all the way over to the left side. Then bring your finger up. 5, make sure to clean your fingers after each row. 6, continue the same method for the rest of the 4 fingers and the left hand. 7, on the last row in the first block will be for your left 4 fingers, minus your thumb. Individually rub each finger in the ink, then place these 4 fingers at an angle and pull up. Next block is for your left thumb, using the same method. Next block is for your right thumb, using the same method. 10, last block is for your right 4 fingers minus the thumb, using the same method you did with the left 4 fingers. Logbook/form report. Keywords. Delta, a point and loop and whirl prints that lies within an often triangular 3-pronged or funnel-shaped structure. It is the part of a ridge nearest the point where 2 parallel ridge lines. Loop, prints that recurve back on themselves to form a loop shape. Whirl, circular or spiral patterns like tiny whirlpools. arch. Create a wave-like pattern and include plain arches and tinted arches. Loupe. A loupe is a simple, small magnification device used to see small details more closely. Fingerprint prints. Arch, plain, arch, tinted, loop, and whirl. My resources that I use is encyclopedia2.thefreedictionary.com/loop+pattern, www.fi.edu/math-patterns-nature. Last one I used was www.forensicsciencesimplified.org. Here are a few ways to get the stained ink off your hands. Rubbing alcohol, glass cleaner, spray some hairspray on the affected areas, let it sit for a while until it dissolves the ink, then wash it off. And then the last thing is baby oil. I recommend baby oil. Conclusion. In conclusion, it was a success in putting the ink down on the fingerprint cards. There were more delta in some of my fingers than others. Also, some fingerprints needed more analyzation than others. One con is that the ink stains your fingers, but I'll find a solution on how to clear that up. My Lupe magnifier has a white and blue LED light to help me see the fingerprint pattern better. I had no problem in getting the fingerprints on there, and it was fun to see the difference in the fingerprints. Right hand fingerprint analysis. My thumb. On my right thumb on the first row, I used the Lupe magnifier with the LED light. My right thumb pattern goes in a spiral, a whirl-like print. A spiral is a curved pattern that focuses on a center point and a series of circular shapes that revolve around it. Deltas are the dark spirals around the center of the loop. With the blue LED light in the Lupe, the spirals are darker and they pop out more to see the pattern, as you can see on the right. Index. My index finger is more of a central pocket loop, a type of print pattern that has two deltas and at least one friction ridge that makes one complete circuit, which may be spiral, oval, circular, or any variant of a circle. Middle. Radial loop is the pattern for this finger. It's not fully in a spiral, but a loop. A radial loop is characterized by a flow of the pattern that opens in the direction of the radius. Ring. Normal whirl. Just a spiral, more defined, but defined/sharp with blue light. Pinky. An accidental whirl. This whirl is a type of print pattern consisting of the combination of two different types of patterns, including the plain arch, with two or more deltas. This is my left hand fingerprint analysis. My thumb. A whirl, more defined, with blotches of delta and swirls. Index. Plain whirl, more defined with delta. Middle. A central pocket loop. Delta in the inner spiral. A central pocket loop is a type of print pattern that has two deltas and at least one friction ridge that makes one complete circuit. My ring finger. Loop. Delta curving loops. A lot of delta right here. Pinky. An ulnar loop. Tinted arch. Delta ulnar loop. A fingerprint or palm print pattern that consists of a loop which opens toward the ulnar side of the hand, toward the pinky. Compare and contrast right and left hand fingerprints. Right hand fingers. On my right hand, my fingers have similar patterns. It could be because it's my most dominant hand. Left hand fingers. On my left hand, my fingers have different patterns from my right hand. I feel as though from a far distance they both look alike, but if you look more in depth, they are completely different. Here is my complete fingerprint analysis. My bibliography. Here are the resources I used: encyclopedia2.thefreedictionary.com, www.fi.edu, www.forensicsciencesimplified.org, and www.youtube.com. This experiment was really fun to do. I hope you enjoyed my presentation.
Alright guys, today I'll be showing you my science fair presentation, the study of background noise and concentration. Here are a few photos. Abstract. I'll be making a test that has 10 levels. These levels will have different noises to it. My subject that will be taking the test will be my family. They cannot laugh, look away, pause, unless turning the page, or have a long stutter. This test will let the person read a book on their level. They must read until they can't read or concentrate anymore. Once they can't read or concentrate, the test will be over. The purpose. The reason I will be doing this project is because I want to see how many levels of background noise a person can take before a person's concentration breaks. Question. How much background noise can a person take before they get distracted and break their concentration? Hypothesis. I believe that if I make a hard task that takes extreme concentration with background noise, we will see what level of background noise can break that person's concentration. Background research. I would like to say the site I found all my information was www.healthlinkbc and Google and YouTube. Materials. I used a phone, a book, human helpers, and a notebook. Procedures. Have one person sitting in a chair, have another person record, have another person put on the noise, then have the person sitting in the chair read. Once they stop and lose their concentration, move to the next person. You need 4 to 5 people. Results. When my mom, my dad, and my brother got to the car, they lost. The car was level 2. When me and my sister lost, we got to the vacuum cleaner. The vacuum cleaner was level 3. Conclusion. It turns out my hypothesis was accurate. I put each person to the task of reading, including myself, which can take a lot of concentration, and saw the level of concentration a person can take, which turns out to be levels 1 to 3. The levels that will be in this video are 1. Argument, 2. Car sounds, 3. Vacuum cleaner, 4. Lawnmower, 5. Subway sounds, 6. A BMW S1000RR dyno, which is a motorcycle, 7. Chainsaw, 8. Police sirens, and 9. An AK-47. And now I will be showing you my video. Alright guys, so now I shall be showing you my video. Please enjoy. Hello guys, my name is Daryl Edwards, and I am an 8th grade student. Today I will be showing you my science fair project. I'm pretty sure the me that already read the Google Slides has already told you what's going to be happening. So the me now will be showing you how. Alright guys, so for the first person that's going to be taking this background noise test is my mother. And if you didn't see the rules or know the rules of how this background test works, I'm going to be showing you them right now. Okay guys, now that you saw the rules, on with the test.
Prologue. May 22nd, 1950. He had a few more minutes to destroy 17 years of evidence. Still in his pajamas, Gary Gould raced around his cultic bathroom, pulling out a desk drawer, tossing boxes of the closet and yanking books from the shelves. He was horrified. Everywhere he looked was
Alright guys, so as you can see, my mom lost at level 2. Now, we're going to move on to somebody else. This time it will be a male, which will be my father, and we shall see what level he can be.
He had a few more minutes to destroy 17 years of evidence. Still in pajamas, Harry Gold raced around his cultured bedroom, pulling out desk drawers, tossing boxes out of the closet, and yanking books from the shelves. He was horrified. Everywhere he looked were incriminating papers, a plane ticket, a stub, a secret report, a letter from a fellow spy. Gold ripped the papers of shreds carried to the fist.
Wow. So, well, guys, you can see at the end of that clip, my father laughed and broke his concentration. So, he lost at level 2, the same level my mom lost at. And now we will be going back to a female, which will be my sister, who will be reading her science book.
How stems help plants? A stems plant hold up its leaf, flowers, and fruit. Most plant stems have tubs that move water and materials from the roots of the plant to the leaves. Other tubes carry food from the roots to the leaves. Other plants carry food. The pictures show different kinds of stems. Some stems called solatium are thin and grow along the surface of the ground. These stems can grow roots in a new plant. Some stems called vines grow parts that wrap around objects that support the plant. Notice how thick contour stems can be. Contour stems shell up as the store water. The stems sharp as the plant use water help keep from losing water. This type of stems help the plant survive in a desert. Some of the stems grow underground.
Hey guys, so as you can see in that video, my sister made it to level 3, surprisingly. And now we're going to the last person, which will be my little brother.
How many beaks do you have? 1. How many ears do you have? 2. How many eyes do you have? 3. How many wobbly legs do you have? 4. How many?
Stop. Guys, so as you can see, my brother made it to level 2 reading his own book. And for this last video, it's just an extra clip of me attempting to do my own challenge. Prologue, May 22, 1950. He had a few more minutes to destroy 17 years of evidence. Still in pajamas, Harry Gold raced around his cluttered bedroom, pulling out desk drawers, tossing boxes out of the closet, and yanking books from the shelves. He was horrified. Everywhere he looked were incriminated papers, a plane ticket stub, a secret report, a letter from a fellow spy. Gold ripped the papers to shreds, carried 2 fistfuls of to the bedroom, shoved them into the toilet, and flushed. Then he ran back into the bedroom, grabbed the rest of the pile, and stumbled on slippers down the stairs to the cellars, where he pushed the stuff to the bottom of the overflowing garbage can. The doorbell rang. Gold walked to the door. He took a few deep breaths, trying to slow his heartbeat down, then opened the door and saw the men he expected. Federal Bureau of Investigating Agents Scott Miller and Richard Brannan. They've been questioning Gold for days, showing him the pictures of new... Alright, so as you can see in that video, I did my own challenge and made it to level 3, right along with my sister who made it to level 3. Everybody else made it to level 2. And that concludes my science fair project, and I hope you enjoyed it. Thank you for listening, and...
Good morning, CCA. My name is JH here, and this is my project about molded soggy bread. The question and purpose of my project is, what would happen to the mold on bread if it gets soggy? My purpose in this experiment is to figure out whether or not mold can be affected by water. I know how it feels when you're about to make one of your favorite sandwiches or whatever you use bread for, and the bread is moldy, so you can't use it. Hypothesis: if mold grows on this ugly piece of bread, how will it look like and what will it do? Research: when I found things in magazines or talked to people about moldy bread, they usually had very angry faces. But when I brought up the topic about water and moldy bread, most of them started to laugh. Materials: 4 Ziploc bags, a permanent marker, 4 pieces of bread, a sink or a water rag or paper towels, tinfoil, and gloves. Procedures: first, label your 4 Ziploc bags with your permanent marker. Control: dirty hand, clean hand, dirty surface. Number 2. Using a glove or tongs, carefully place a piece of bread into the control bag and seal it. Be sure not to touch it with anything else besides the gloves or tongs. This will be the piece of bread that you can use to compare to others. Number 3. Remove a piece of bread and press your unwashed hands into it. Place it into the dirty hand bag and seal it. 4. Wash your hands with soap and warm water for at least 20 seconds. Make sure to scrub all the germs away. Repeat this process as you did for the dirty hand bag using your clean hand. Place this piece of bread into your clean hand bag and seal it. Number 5. Remove another piece of bread. Rub it onto a dirty surface of your choice, etc. Floor, bottom of a shoe, doorknob, anything. Place this bread into the dirty surface bag and seal it. Procedures: continue. Last and final step. Place all bags into a safe place. Be sure not to open any of the bags. Return to the bags each day and observe the change. Expect to see results after about a week when using baker's bread. Result and conclusion. The result: when I finished doing the experiment, and about after a couple of days, the 2 pieces of bread that were moldy and watery, they looked normal for soggy bread because of the mold. It spread into the middle of the bread and never moved out because of the water. The other 2 clean bread had a little bit of mold on it, and they smelled very bad. Conclusion: it was fun and wakeful, and the mold was very disgusting. Thank you.
Hello, and welcome to my science fair project. In this experiment, I answered the question, how does water purity affect surface tension? Table of contents. So this just shows on what sides I will be talking about which topic. We have abstract, purpose, hypothesis, materials, procedure, results, conclusion, and pictures. Abstract. I began this experiment by collecting all of the necessary materials. Most of the items were easily found in my household, but I had to purchase the remaining materials. The question I wanted to answer was, how does water purity affect surface tension? After testing my experiment, I learned that the answer to my question was easy. First, I filled 3 separate glasses with purified water. Second, I placed small pieces of paper towels on the surface of each glass. Next, I put 1 paper clip on top of each piece of paper towel. Then, using the tip of a pen and my finger, I pushed the paper towel farther down into the water so that I was no longer touching the paper clip. I did each step one at a time. The first glass of water I tested, I left untouched by the soap or dishwashing liquid. This glass's paperclip stayed at the surface and did not sink. Next, I tested another glass, filling that one with 5 drops of dish soap. It didn't take long before the paperclip sunk to the bottom of the glass. Finally, I tested the last glass by dropping 5 drops of salt. This glass's paperclip also soon fell to the bottom. I quickly came to the conclusion that the pure water had the highest surface tension, allowing the paperclip to stay afloat. Low surface tension is what caused the paperclips in the other 2 glasses of soapy water and salted water to sink. My hypothesis, which was, if I compare the surface tensions of pure, soapy, and salted water, the pure and salted waters will have the highest surface tension and allow the paperclip to float because while they aren't equally pure, salted water has qualities that will allow high-density objects to float, was half correct. So my purpose for doing this experiment was because I was curious as to how different levels of water purity affects its surface tension and why. My hypothesis was if I compare the surface tension of pure, soapy, and salted water, the pure and salted waters will have the highest surface tension and allow the paperclip to float because while they aren't equally pure, salted water is natural and has qualities that will allow high-density objects to float. My materials included 3 drinking glasses, purified water, 5 drops of dish detergent, 5 drops of salt, dropper or measuring syringe, paper towels, and 1 paperclip, steel paperclip. My procedure, which was the steps I followed to conduct this experiment. Gather 3 drinking glasses, fill each glass with bottled purified water, float a small piece of paper towel on the surface of each glass, place a paperclip on top of each paper towel, push the paperclips down into the water so that it is no longer touching the paper clips. Carefully remove the paper towels. Add 5 dish detergent drops to glass number 2. Add 5 drops of salt to glass number 3. Observe the surface tension and how each paperclip reacts to being on the surface of each glass of water, whether or not it floats or sinks. And lastly, to record results and observations. The results. So as you can see by the graph on the left, the pure water, it floated on pure water and it sunk on both dish detergent water and salt water. And on the right here it says, when I tested my experiment, the results came quickly. As shown in the table above, the 2 water samples that failed to float were the ones containing dish soap liquid and the other containing salt. Unlike the soapy sample, the salty water's paperclip did not immediately sink to the bottom of the glass, which made me think that maybe it would stay afloat like the pure water's paperclip. However, after a few seconds, it finally sank. Conclusion. In conclusion, my hypothesis was half correct. I believe that the paperclip will float in both pure and salted water. This means that contrary to my hypothesis, the pure water had the highest surface tension, followed by the salt water, then the soapy water. Here are some pictures that sort of represent my experiment. Thank you all for watching.
Bubblegum. Question. How does the brand of bubblegum affect the size of a bubble blown? Hypothesis. If I eat more than 1 piece of gum, then the bubble will be bigger than it would if I was to only eat 1 piece of gum. How is gum made? Most modern gums are based on a synthetic equivalent of rubbery material called polyester butylene that's also used in manufacture of inner tubes. Polyester butylene is mixed with plasticizers and materials, all food grade, to make the gum mixture chewable. Materials needed: gum, all different brands, and a willing participant. Pineapple Trident gum. The first piece tastes like pineapple, and it should because that's the flavor of it. And then it turned into like an orange taste, which I was kind of disappointed because I've never tried pineapple gum, but at first it was good, and then it turned into an orange flavor. Second piece, it was thick and hard to chew, and I could not make a bubble. It tastes like oranges now. which I was still a little upset about because it was supposed to taste like pineapple. But the more I chewed it, the thinner it was getting. And then the third piece, it was really thick. It was harder to chew to the point where it was hurting my jaw, and it still had flavor. Fourth piece, I could not chew it really because it was really thick and I could not make bubbles. And it had no more flavor. Citrus Orbit. First piece. It was hard at first and it tastes like tangerine, but it it got really soft. Like at first, like I said, it was hard and then it tasted softer. Second piece. It had a strong taste. It was hard to chew and it did not get soft and it was losing flavor. Third piece. It tastes even stronger and it did not get any softer. I was refusing to eat another piece because it was getting really thick. Icebreaker's Ice Cube, Wintergreen. First piece, it kind of tasted, it was kind of spicy, and then it got really thin, and I could make bubbles, but it was burning my nose. Second piece, it got, as I was chewing it, it got thicker, and it was getting harder to chew and a little less flavor, and it was still burning my nose. Which I was confused about this one because I thought, like, my I thought as I was going to be adding more and more pieces of gum to my mouth, I thought it was going to bring more flavor, but it was actually losing flavor, which once again I was a little disappointed in because, yeah, I was really looking forward to chewing some good tasting gum. And I did not want to chew another piece because it was really burning my nose. Then we have the Wrigley's Winter Fresh. First piece, it was minty, it was very soft, and it was getting stuck to my braces. Second piece, it was getting stiff and it was losing flavor, which once again, I was a little confused because I thought that it was going to add more flavor to it, but it made it lose flavor. And I did not want to chew anymore because once again, it was getting stuck in my braces and I was going to break a bracket. Wrigley's Big Red Gum. First piece. At first, it was sweet, and then it got really spicy and burned my nostrils. It was a little too hot on my tongue to blow a bubble. Second piece. It got stuck in my braces. It was thick, and it had lots of flavor. Now, this one, I could not chew anymore because it was really hot, and it had a lot of flavor, unlike the other ones where I was adding more and more pieces to my gum, and it was losing flavor. Wrigley's Juicy Fruit. First piece. It was hard at first, like it was stale, and then it was getting softer as I chewed it. It had lots of flavor, of course, because Juicy Fruit is the best gum. It was not completely soft, but it was softer, and the bubbles were amazing. Second piece. It was harder, like it made, as I was chewing the first piece, it was getting softer. Then, as I added the second piece to my mouth, it made the first piece of gum harder than it was. So I had to put in more work into making it soft again. And then the flavor just completely left and I could not make a bubble. The purpose of this project is to see how all different gum brands can blow a bubble and how big they are. Per procedure. Step 1. Buy all different types of bubble gum or chewing gum. Step 2. Find a willing participant that is willing to chew multiple pieces of gum at a time. Step 3. Chew one piece of gum and continue to add more and more pieces of gum to your mouth. Step 4. Record and parentheses write down how the gum tastes after a couple of minutes. Conclusion. Chewing multiple pieces of gum had the same purpose overall, but found a slight difference in each brand. I noticed some gum was harder to chew than others. The flavors seemed to fade faster than some other brands. The cost of each gum varied from the quantity size. I enjoyed making bubbles with my gum, and some brands were not successful. Gum is designed to chew, and I did just that with each other brand. but learned they're the same but different, and will put more consideration into my purchase when buying gum, which I do buy gum, but I don't buy that often because I have braces. The experiment was exciting and shocking at the same time due to information I learned about gum.
Hi, this is our science fair project about slime and oobleck. Purpose. The purpose for us doing this experiment was so that we could show that when you mix two children toys together, it can make one whole toy that will be fun to play with. Question. If we mix slime and oobleck together, what will happen? Hypothesis. If we put the slime onto the oobleck, it then might melt or stay on, or in the oobleck, because the slime is either liquidy or hard, but I know it will become liquidy. Materials for slime: glue, food coloring, and water, and borax. Materials for oobleck: water and cornstarch. Procedure. First, you have to get all the ingredients. Second, you have to mix the ingredients by itself. Third, you have to mix them up together to make your experiment. Results. The results was that it was very messy, but it came out good and it won't stick to your hands that much. So it's safe to do the projects, and the results are that slime and oobleck can mix. Conclusion. I found out that I can prove my question. This is the final project. Thank you for watching our slime oobleck project. Have a great day.
Good evening, 8th grade. This is Sanaya coming to you with conducting and testing my own shampoo. Science Fair 2021. You may ask me, what was my purpose? Well, my purpose in doing this project that involves testing shampoos or comparing two different ones, which will be a homemade and a store-bought one, was because in the future, I would love to be a cosmetologist, as you may know. In that job, it involves shampoos, what you use in your customers' hair, and etc. As a kid, it's great to know about shampoos at a young age because, there is something called a future. This is my abstract. I first tested my project, I believe, lied to you not, I'm sorry if I'm lying, on March 8th. I tested the store-bought one on last week Monday. So the first picture is when it first came out of some box braids. And let me tell you, when I did the box braids, I put I didn't put tons, but I put enough for it to be clumped together of gel. So that's why it looked like that. And as the top, it was worse because it was so much harder and stuff, The second one was when it was washed and rinsed. I used the VO5 shampoo. I got it from my local Walmart. And on the third slide, that is when it was combed, detangled, and combed out. Abstract part 2, testing the homemade shampoo. As you can see, the shampoo does not look like your normal shampoo. Well, that's because the project that I did failed, which I'm not really proud of, but it failed. But at least I still tested it. For the left side of the shampoo, you can see that I took a very bad picture because the mannequin looks kind of like it has a bald spot, like I'm not treating its hair right, but I am, trust me. On the right side of the shampoo, there is it half blow dried and half wet. I didn't really take my time on a blow drying this one because there was no point when I can blow dry in a section. And yeah, my hypothesis, if I put a variety of products together to make a shampoo, then I'll be able to see the difference between homemade and store-bought because of its texture. My materials for homemade shampoo: full-fat coconut milk, honey, jojoba oil, olive oil. It said apple cider vinegar, but all I could find is organic, which is probably one of the reasons that it failed. Essential oil, which is I use tea tree oil, a measuring cup, 4 to 5 ounces, fresh herbs such as thyme, lavender, rosemary,
or herbal tea bag, I use the herbal tea bag. A mannequin head, and the materials for the overall project, I used the mannequin head, VO5 shampoo, water, and a blow dryer. My data. On Monday, I tested my store-bought and I just made the shampoo. I stored my homemade shampoo in a bin for 4 days in the closet. On day 2, which was Tuesday, I checked up on my shampoo. It was still watery. Worst consistency ever. On Wednesday, I checked up on my shampoo. It got a little bit thick. It was an okay consistency. On Thursday, I decided not to check up on the shampoo, so I was surprised at what I'll be working with on the last day, which will be Friday. Sadly, on Friday, I did not appreciate the consistency of my project just because I knew the consistency I was looking for wasn't there. But, it's always another lifetime in life that I can try it. So, in conclusion, you guys should always pick your store-bought shampoo. And let me give you my reason behind this. Because testing your own shampoos, it comes with a lot of directions. You have to have the exact measurements, which I'm not really good with the measurements. I'm okay, and that's probably why my homemade shampoo didn't come out. But I'm not going to give up on making my own shampoo because that can be something I invest myself in. So later on in life, I'll try to make another shampoo and use much better products. So guys, in conclusion, just go to your local Walmart and buy a shampoo or conditioner, and your hair will be perfectly fine. Thank you for listening to my presentation.
That's by Sincere. That was a little awkward. Purpose. I thought of this around Christmas or maybe even before. I wanted to watch all the episodes of The Flash, starting from season 2. And this season, people from another universe called Earth 2 came to this universe called Earth 1. The people from Earth 2 vibrated at a different frequency than the people from Earth 1. That was the main thought for how I would go about the Sand and Oobleck project. Hypothesis. I don't think that the Oobleck nor the sand will dance to sounds that humans can't hear. The reason for this is the frequency and vibrations. I don't think that the vibration will be strong enough to reach the Oobleck or the sand. Even if it does reach the Oobleck or the sand, it shouldn't be strong enough to make the substance move. Materials. For this project, you will need cornstarch and water to make the Oobleck, sand, a speaker, and a cover for a speaker. For example, for like a paper towel, tinfoil, and etc. Procedures. Step 1, add 500 milliliters of cornstarch to a bowl. Step 2, add 250 milliliters of water to that very same bowl. Step 3, add 600 milliliters of water to a small cup. Step 4, place the Oobleck sand on the paper towel. Step 5, place the paper towel onto the small speaker or whatever kind of speaker that you have. Step 6, connect the speaker to a device. Step 7, turn on a sound that is high or low enough to a point where you can't hear it. Step 8, observe very closely to see if the substances do or do not move. This is the normal frequency, Oobleck 440 hertz. The sand, 440 hertz. 440 hertz. Makes your head buzz, doesn't it? Low frequency for the Oobleck, 131 hertz. Man. The Oobleck does seem to spread out. Low frequency for the sand, 134 hertz. Low non-hearing frequency for the oobleck, 5 hertz.
5 hertz.
Low non-hearing frequency for the sand, this is 0 hertz.
0 hertz.
High frequency for the oobleck, 2030 hertz. High frequency for the sand, also 2030 hertz.
9030 hertz.
High non-hearing frequency for the oobleck, 2000 hertz.
20,000 hertz.
20,000 hertz. High non-hearing frequency for the sand, also 20,000 hertz.
20,000 hertz.
As you can see from the results, the low hearing frequency, the oobleck was moving as well as the sand. From the low non-hearing frequency, the oobleck nor the sand were moving. From the high frequency, the oobleck was not moving, but the sand was. And from the high non-hearing frequency, the oobleck nor the sand was moving. Conclusion. So in conclusion, my hypothesis was correct. Yet, to this day, I still cannot determine why, for which reasoning. Whether it being because the sound was not strong enough to move the substance or the vibrations did not reach it. It could very well be both, but one thing's for sure, it definitely wasn't either. Thank you.
Hello, Cornerstone, and congratulations, middle school students, on another awesome virtual science fair. My hat is off to you for taking all of your findings, all of your experimentation, and distilling it down into a short video that can be shared virtually. It's no easy feat, and I think it's clear that each and every one of you rose to that challenge. If you could all take home a blue ribbon, I would love to give it to you, because this was really my pleasure to watch through all of these. And I'm super impressed by all of your fact-finding, your thought process, and your presentations. So I'd like to talk about a few of them. A couple that stood out to me in 5th grade was Yuri, your presentation on kinetic energy. I really liked the overall idea behind what you were showcasing, turning something as complex as the transfer of energy into something fun, like a car. And one thing in your presentation that I really liked was the step-by-step process that you showed and how you built the car, and then culminating in the video showcasing your findings. So that made it very entertaining and very clear. Similarly, Bree, your lung health presentation was not only a great thing to study because it has such wider implications beyond this science fair, but it was presented in an interesting way, and showing the device at the end and how it was working and how you drew your conclusions from how it worked really made me feel like I was at an old school live science fair and not watching it on screen. So really nice job on that one. In 6th grade, Gage, I really liked your analysis of mold growing, and some of the voiceover, or well, the captioning was funny and kept me engaged throughout it. But one thing that a lot of you ran into, and Gage did as well, is when you tested your hypothesis, you found a different result. And instead of finding that to be, a failure or something negative, you took it as a positive. And that's exactly what the scientific process is supposed to be about. You test your hypothesis, and then you record and you learn from those results, regardless of what they are, because the experiment bears out at least some element of truth, and you follow that to the next logical step. So nice job in sticking with it. Another 6th grade presentation I liked was Jalen's Why Doesn't the Ocean Freeze? Now, this is a question I ask myself all the time. Our hypotheses were the same, the saltwater content, right? And again, your process was very, very clear. It was presented in a concise way that I could follow along with, and you presented your conclusion very, very nicely. One other thing I'll mention, because I am the marketing guy, once we do our experiments and we draw our conclusions, the next step is sharing that information with an audience. Now, that might be for a scientific research paper, it might be for something for school, or in this case, for a wider audience. So you want to take those findings and make them as clear and easy to understand as possible. So I thought your chart at the end is a great way of doing it. Whenever you can take complex information, distill it down into an easily digestible visual form is a great way to get your point across quickly and easily. So good job. In 7th grade, I really liked Nicholas Dreckett's snail experiment, especially that no animals were harmed during the making of that presentation. But getting the up-close video of the snails doing their thing, again, really made me feel like I was at the science fair and I could get up close and personal with what you were studying. Your presentation was great, your conclusions were strong, and you tested your hypothesis perfectly. Also in 7th, I really enjoyed Haley's coffee experiment. Again, a topic that's near and dear to my heart, but I really, really liked how you approached testing your hypothesis with not one, but 2 different studies. So you had them play the game, but then also check those results with the blood pressure analysis, which is a really great and thorough exploration of your hypothesis, and it yielded the result that you thought, so that's wonderful too, but really a good approach. And then in 8th, I really liked David Armstrong's candle and water suction experiment. Again, made me feel like I was right alongside you watching that happen and taking notes on it as if it was a real science fair. Ayana's, what was it? Oh, the surface tension project. Again, to talk about the presentation style, your presentation was extremely clear and extremely neat. And, again, marketing, it's important to keep people engaged and keep them informed and have them follow along with the information that you're trying to share. The information also was presented clearly. Again, your hypothesis was disproven, and I would have thought the same thing that you did. But it was great to see how you studied it, what you observed, and how what you took away at the end was the scientific fact rather than what our expectation was on the front end. So all in all, everybody, again, did a really wonderful job. I learned a lot, I laughed a lot, and I couldn't be prouder of our school and of all of you, as well as Ms. Grant and Mr. Samawar and everyone else who helped put these presentations together. So again, one last round of applause for each and every one of you, and I will see you next year.
Hey, Ryan Kramer here from BSD Education. I want to tell all the students who participated in the science fair that they did an exceptional job. The projects were well organized with clear hypotheses, objectives, and procedures. I really enjoyed when photos and videos were included, which helped explain and visualize the experiments. I'd like to add that experiments are not successes or failures based on whether your hypothesis was correct or not. If you see an experiment to its end, have accurate recordings, and are able to come up with a conclusion, then it was successful. Getting a negative result to your hypothesis is not only a valid conclusion, but will most likely be the case when testing something new. You'll often learn more when things don't go as expected than when they do. To continue on with your learning, I would suggest revisiting your experiment and determining the different variables that can be altered. You can conduct brand new experiments and expand your findings by changing a few things around. For instance, if you were timing something, include new timeframes into the observation. If you were dealing with specific measurements of materials, change those up to see the results. Just remember that the most scientific way to compare data is to make changes to one item at a time. So for the classic volcano experiment, changing the amount of vinegar, baking soda, and water, and running the experiment with each new adjustment. Awesome job to everyone. These were very impressive projects. The attention to detail and level of dedication should make you all very proud. Some of these experiments took many days. then to collect and process your findings, organize them as presentations, and record it all, even bringing in photos and videos, is all very impressive. Well done.
Hello, Cornerstone Christian Academy. This is Dr. Herb Green from Temple, formerly a Philadelphia public school math and computer science teacher. Thanks to Mr. Samawar for inviting me to look at your amazing science projects. I have some feedback for you, and I'd like to start out with the study of background noise and concentration by D.E. I found out that D.E. was Daryl Edwards. Now, Daryl, what you did well was chose a timely topic, and you delivered an excellent presentation. Your design showed careful planning and involving your family in a friendly reading competition, but with a book of their own choosing. That helped reduce some variation. You used common annoying noises that everyone would recognize, and you wanted to see how long your family could read something without being distracted. It's a very fascinating experiment. And then you filmed them so we could actually see the result of the different noises. What you can do to continue learning about these concepts? What if you repeated this experiment with the same people, or with people of different ages, or with people of the same age? Would the results be the same? Interesting. And then, bigger question, what can we do to reduce noise distraction of people trying to work or study? How do you do your best studying? What noises can help people be more effective at work or study or play? What about noise and sleep habits? Plenty of room for research there. On a personal note, I hope you thanked your family for their courage, patience, and gracious cooperation. Personally, I played classical music softly in my math classroom because I read research that classical music helps the brain learn new or difficult material. How about that? I hope you'll continue your investigation of this and other phenomena that interest you and your family and friends. Would you consider researching the effect of loud noises on a person's hearing over time? The reason I ask is because personally, I have a hearing loss, and I wonder if all those lawns I mowed when I was in high school to make some money had any effect on my hearing. So thank you, Daryl. All right, my second research project that I looked at was by Jade. She talked about making her own fingerprint analysis. What you did well, Jade, was your slides, the organization that you put together, and your voice, your tone of voice was very conducive to giving people confidence, including me, to follow and to do my own fingerprint analysis. So what can you do to continue learning about fingerprints? I encourage you to check into the FBI website and see how they handle fingerprints, and then research what relevant jobs are now available. Also, what's the future look like for people in that field? You know, every teacher and caregiver has to get in Pennsylvania, has to get a fingerprint, have to submit to fingerprint, not analysis, but it's a criminal background check. We get fingerprinted and they send it to the FBI and they say, okay, you're okay, or no, you shouldn't be working with kids. So I've had my fingerprints taken, but I've never analyzed them myself. Okay. In terms of majors, you wanted to study math and science in high school, of course, and then you could look at Temple University, where I'm teaching, into their criminal investigation major. Okay, and then there'll be a lot of well-paying jobs available to you if you major in math and science or in criminal investigation. On a personal note, I recommend that you watch some episodes of the TV FBI drama called Numbers. There are lesson plans and there are episodes online. So you can watch the episode, but then you can look at the lessons that come out of that episode. And it's all about a brother who's an FBI leader and his brother who's a mathematician at, I think it's Caltech. And so when the leader of the FBI gets a really difficult case, he calls on his brother, the mathematician, to see if he could figure something out. And often he does, using math. So I was inspired to use some of those lesson plans that were posted online with my students in the high school where I was. So I recommend it highly. All right, number 3. For those of us who like to dance, Sincere decided to study the effect of high-frequency sounds that we can't hear. Well, it could be low frequency. Sounds that we can't hear. And would they have any effect on sand or oobleck? And he tells you what oobleck is and how to make it. So I like the inspiration that you had, Sincere, because you mentioned Flash, the series, the TV series, and I'm a big fan of Flash comics, and then I really got into the TV series. What motivated you to look into this problem was on the show they talked about a parallel Earth where the people vibrated at a different frequency than our Earth. They were Earth 2 and we're Earth 1 or Earth. You did a good job with your hypothesis, materials, procedure, your results, and your conclusion. What can you do to continue your learning about the effect of sound on materials? Well, you could research the effect of sound on fish and mammals and see if we, humans, are hurting sea animals with our sonar investigation. I believe the Navy is studying this right now. I also recommend that you study physics in high school, where you can get into sound, the science of sound, a lot deeper. And then the question is, what are the medical uses for sound? Can sound be used to eliminate surgery on some ailments? I recommend you investigate careers related to sound. Here's one example to research. Are teenagers in danger of losing their hearing from listening to loud music or using earbuds? Fourth, I looked into Sanaya Brown's conducting, or I think she meant creating, and testing your own shampoo. This interested me. Anyway, Sanaya, you connected your project to the career of cosmetology and shared that you would like to pursue this for your future. My daughter studied cosmetology, so that got me interested too. What can you do to continue your learning of these concepts? I was wondering if you had spoken to your local hairdressers about what shampoos they prefer and why. Now, you may have already done this, but if you haven't, could you ask them about the ingredients that constitute a quality shampoo? How close were your ingredients that you used to the ones that they recommended? And then my other question is, what about conditioners? You should study chemistry in high school because hair treatments depend on chemicals. It's all about chemistry. Have you considered doing a comparison test with 3 of the most popular shampoos? You could take the recommendations of your hairdressers and your family. The career of chemist could provide you with a job where you could solve many challenging problems and even invent an outstanding shampoo. On a personal note, my wife convinced me to use a separate conditioner instead of my go-to combination product. I'm doing a comparison shampooing and conditioning with her as my science project judge. Number 5, the Water Vacuum Project by David Armstrong. David, what you did well was explaining what you were doing as you showed us the video of the experiment, take 1 and take 2. Doing it again with a change of one variable is what scientists do. You explained your materials, procedure, and results. What you can do to continue your learning of some of these concepts, you can check out chemistry and other science and math courses in high school. They'll prepare you for a career in science. If you are a curious person, and I think you are, being a scientist provides endless possibilities to observe life, think about what is and what is not working well, and then to design ways to solve the problems or improve the quality of life of people. I highly recommend you investigate fragileoasis.org. It's a worldwide water project begun by astronaut Ron Garan. He was inspired by the view he and his fellow space station astronauts had of our fragile oasis, Earth. He called it the orbital perspective. You can learn more about his initiative to bring clean water to the more than 1 billion people on Earth who don't have access to clean drinking water, and also help bring food to the large number of people who don't have it, along with other needs. Here's just one example of his inspiring others. It's a TED Talk. I'll send it to Mr. Samawar so you'll have it. Okay? Basically a TED Talk. You can look up Ron Garan, Garan. On a personal note, I had the privilege of speaking with him on a cell phone as he orbited the Earth in the space station. And since he knew I was a Philadelphia math teacher, he talked about some of the student projects that had been submitted and put on the space station. There's a video of him doing a biology. I don't think it was a student biology project, but he was doing one on the station. So I thought that was interesting. Check it out. Ron Garan, astronaut. All right. My next one, number 6, is KP's investigation of bubblegum. Different kinds of bubblegum. Okay, what you did well, KP, was systematically describing through pictures and commentary which brands of gum you tried and how they performed as you tried 1, 2, or 3 pieces. You were mindful to think about the interaction of your braces and the gum brands. It's interesting to find out that some of them you couldn't blow bubbles at all with the gum. All right, what can you do to learn more about these concepts? Well, one question I had for you is, what would you do differently if you repeat this experiment? And what would happen if you use regular versions of gum instead of the sugar-free? And then how would you I was wondering, how would you measure the bubbles, the size of the bubbles that you're blowing? Okay, what can you do to continue your learning? You can study biology, chemistry, and higher math in high school. You can visit some food labs and see how they test potential new products. What are the advantages and disadvantages of sugar-free gum or other sugar-free products? On a personal note, I wonder why some gums lose their flavor quickly while others keep their flavor over time. I also wonder why some people throw gum on the sidewalk and deposit it on their desk or on their chair. That really bothered me as a teacher, and it still bothers me to see that. So. All right, number 7. How would you extract your own DNA? Well, Cache Livingston, I hope I pronounced that right, Cache, she did that experiment. She did well to use slides with the representation of the DNA double helix and pictures of the containers with colored samples that she used. She explained her procedure and materials very well. What can you do to continue your learning of some of these concepts? Well, I would recommend you look up Rosalind Franklin and find out why she wasn't at first credited with discovering the structure of DNA. In high school, you could study chemistry, biology, and physics to prepare for careers in science. We need more women in science. On a personal note, I wonder how many more people in prison could be exonerated by DNA evidence. I wonder when all the stored rape kits that haven't been processed will get processed and for DNA, and matching rapists will be caught. I hope you'll consider a career in science. Number 8. J.H. studied molded soggy bread. Well, this caught my curiosity, my attention, because I was wondering, okay, well, I've seen moldy bread, but I don't know that I've seen soggy moldy bread. So I wanted to know what he was doing and why. So what he did well, J.H., what you did well was you carefully described your procedure and how you organized your samples, which seemed like a mystery that needed to be solved. You captivated this reader. I was very interested to see how you were doing it and then what the results would be. What you can do to continue your learning of some of these concepts, you can investigate the nature of and history of mold, its study, its uses in medicine, food preparation, and prevention of growth and treatments. We've had many floods in the U.S. lately and also around the world. We'll talk about climate change too. But when the water recedes, what can be done about the mold that grows? How can homes be protected against mold? You can study biology and chemistry in high school and investigate science careers that are related. On a personal note, I had an outside drain that was blocked by tree roots. I noticed water coming down the wall in the basement. It was from the rainwater overflowing from the drain. And black mold appeared on the wall inside the basement. So I cut out the sheetrock, cleaned the stones behind it with a bleach solution to get the mold off, and replaced the sheetrock and painted it with what I was told was a mold-resistant paint. That was about 3 years ago. So far, no mold. Oh, I also replaced I had the drain cleared out of the tree roots. So watch out for that. And last but not least, I wish I knew who this was. It says, how does water purity affect surface tension? But the young lady did not put her name on it, so I hope she gets this. So what you did well was you used a question as a title. That made me want to read your presentation. You explained what you would do and why you picked this question. And you explained the process very clearly. What you can do to continue your learning of some of these concepts, check out the Philadelphia Water Department. They have lots of programs for schools and projects for people living in homes and apartments. I have a contact at the water department, and they gave us some booklets about how water is treated in Philadelphia, and I distribute them to some of the schools I work with in North Philadelphia. On a personal note, here's Ron Garan on the International Space Station. He works on a biology project to start the video, and then at the end, he shares with us his stupid astronaut trick, which features, and I think you'll be interested in this, the surface tension of water in space. Have fun watching his trick. It's https://www.youtube.com/watch?v equals, and then I guess it's, you know what, I'm sending it to Mr. Samawar, and you can get it from him. Fun fact, I spoke to Ron Garan on my cell phone while he was orbiting the Earth in the space station, and he knew I was a Philadelphia teacher, so he told me about student projects that were taken on board from students like you. So think about that. I hope you will continue and find a career in science that you like, because we need more women in science. All right, that's it. Dr. Herb Green from Temple University. I work with math and science teachers and math and science majors who want to become teachers. So think about Temple for your future science and math degree. Take care. Thank you for submitting your science project. And Mr. Samawar, thank you for asking me to be a judge.
Okay, everyone, wasn't that fun? Thanks again for tuning in to Cornerstone Christian Academy's second virtual science fair. Now we're going to be going over the judges' picks for first, second, and third place winners for each of the different grades, as well as overall winners. So the results for 5th grade are For first place, IW for smokers' lungs versus non-smokers' lungs. In second place, we have YG with how does kinetic energy work. For third place, we have a two-way split with LB volcano eruptions and JM homemade lava lamps. For sixth grade, we have GJ, what food will gather mold the fastest. In second place, we have JA, why doesn't the ocean freeze? And in third place, we have KG, what substance grows herbs faster? In seventh grade, we have for first place ND, the effect of temperature on snails' activity. In second place, we have a three-way tie between a few students. DM's project was effect of sunlight on plants and the process of photosynthesis. HP did a project on how does coffee affect the alertness of the human brain. AG, how does color affect eyesight? In third place, we had DJ, what makes ice melt faster? In eighth grade, we have first place DE, the study of background noise on concentration. In second place, we have AH, how does water purity affect surface tension? In third place, we had a three-way tie between a few different projects. One group, DA, JS, YG, they did a project called the Vacuum Project. SWM had a project called Will It Dance. And JH had a project Molded Soggy Bread. And finally, these were the overall picks, regardless of the grade level. Judges were asked to just pick their overall top projects based on the quality of the project, and this is what they voted for. For first place, they have MD, the effect of temperature on snails' activity level. In second place, we have HP, how does coffee affect the alertness of the human brain? And third place, we have IW with smokers' lungs versus non-smokers' lungs. So again, there you have it. The judges have spoken. Thank you again so much for tuning in tonight. There was a lot of hard work behind the scenes between our students, the faculty, as well as our judges. And again, thank you so much to the parents as well as the administration for supporting this great event. Again, we will be touching base with the different winners next week, so you might be, receiving some kind of small prize from us. But again, we just want to say thank you to all the students who worked so hard and put forth their best effort despite many challenges. So again, thank you from the bottom of our hearts, and we are really proud and we are inspired by some of the things that you guys have to say as well as share with the greater scientific community. And it really just goes to show you that science is everywhere. It's not just something that happens in, Miss Grant's class, but it's all around you. So that's something that we want you to take away, and we want you to continue exploring, discovering, and seeing how science can make a difference in your life. Thank you so much, and have a great night.